Hi friends, my name is Souvik Basu. I am a senior consultant with ThoughtWorks. Today we are going to talk about responsive MVVM. Responsive MVVM, probably one of the most important words in UI development. So let's try to explore today how can we achieve responsiveness in UI using MVVM. Before we get into the actual problems and their solutions, let's try to define our terms. What exactly do we mean by responsiveness in UI and what exactly is MVVM? So when we talk about responsiveness, it's two ways in which a UI is said to be responsive. One is the direction from your application to your UI. So my application has some states. Whenever my application state changes, the UI has to show these changes on my application. And this has to happen in instantaneous, continuous and non-blocking manner. Instantaneous means whenever my application state changes, the UI should be able to show the change instantaneously. Continuous is as and when my application states are changing, my UI should keep updated with that and should show the change continuously. And non-blocking, if my application is working on a CPU intensive task or is waiting on some resource, or let's say it has made some web service call and is not able to really complete the task, this should not block my UI from being responsive, and it should free up for the user to interact on the user interface. And then the other part of responsiveness is in the reverse direction from the UI to your application, which means if my application is involved in some heavy operations, my UI should be freed up so that the user can interact with the UI and initiate some other tasks simultaneously. Okay, so how was it achieved traditionally? So this was, it's a no-brainer actually. This is how things have been done for ages. Asynchronous model is probably the most used pattern in UI development, wherein you say whenever my user initiates a task from the UI, you call the underlying model to do the operation, but the UI should not wait for the model to complete its task and then show the results on the UI. Because by the time you are doing your operations, your user interface might just hang if it's using the same thread, and your user may actually not be able to interact with your application at all. So what we use is an asynchronous operation wherein the user interface says that, okay, if you have initiated this operation, I'll just do it in a separate thread and let the underlying model do the operation to modify the UI controls. That means, and this thread is called the dispatcher. So whenever I initialize my application, my dispatcher makes sure of initializing all my UI controls. But if I want to update any property on the UI control, I have to make sure that I use the dispatcher control. So when the results come back, let's say if I have clicked on a button to initiate some task, the UI has sent the logic to the application, the underlying model. The underlying model computes the value, sends the results back. Now I have to check whether I want to show the results on a text box, but I cannot directly say textbox.text is equal to the new value. I have to check whether I am running on the dispatcher thread. If I am not running, I have to make sure that I invoke this operation using the dispatcher. So these were kind of a little bit of bits and pieces that the UI developers always had to follow. Otherwise, you'll get a runtime exception saying that the thread which you are trying to use is not the one which created the control. All this scenario kind of dramatically changed with the feature of data binding. This is, yeah. Sure. Yes, all UI controls wherever you want to update any kind of property on any UI control. So let's say if I have a button, I want to change the background of the button, I cannot directly change it. I have to first of all get the dispatcher of that button and then change it. Yeah. So this was actually one of the biggest problems in traditional UI development, that whenever your results are back, you have to actually search through your UI DOM model, not DOM, I mean whatever object model you have in the UI, you have to search the exact control that you want to update using some ID or the name property, and then after finding the control, you have to use the dispatcher to update its value. So this was, in fact, you have picked out a very good point. these are one of the few problems that we had in traditional UI development. Like whenever my results are back, I had to do a lot of tasks around finding out where do I show the results and how do I show my results. So data binding is in fact one of the most used features in WPF. Today we are going to concentrate more on UI development using WPF, and it applies similarly to Silverlight also. So what exactly is data binding? So data binding is a feature wherein I say that, okay, I have declaratively defined my user, the UI, the view of my UI, and the properties in my UI control are bound to the underlying data, which means my data objects property, if I just change those properties, my framework will take care of propagating these property values back to the UI control and showing it up. So I don't have to really touch my UI controls anymore manually. I can just concentrate on my data object and manipulate things around that, and my data binding will make sure that my changed properties are reflected back into the UI. So this is the auto update of my UI controls. I do not have to think about those dispatcher things anymore because I am not dealing with the direct UI controls at all. This eliminates the need to write the code behind to update UI and involves better testability. I'll explain this thing. So if you would have seen in WPF development, every window that you create, there is a .cs file also associated with that. So if I have a button, I want to do anything on the click of a button, we would traditionally create an event handler for the click event of the button, and the handler will be there in the code behind of that window, wherein I will be writing code to update to call my underlying model. So basically I always had to have that code behind associated with a window wherein I will be handling all kinds of events to the UI, and that is the place where my logic to update the UI would also exist. But with data binding, all these things are not really required, and you eliminate the code of the code behind of your UI. And this actually improves your testability a lot. When I'm talking about testability, I'm talking about unit testing. So UI controls are kind of heavyweight classes. It's very difficult to initialize those classes by themselves because they are just not simple C# objects. They involve a lot of UI elements also. So unit testing these kind of classes are very difficult. If you have your code written in the code behind, it becomes very difficult to test those logic, because every time you change your logic, you have to manually test or do some kind of functional testing of your application to check its behavior. So with data binding, we'll soon see how using model view model, this whole UI logic is shifted out of the UI into a data object, and this data object is a plain old C# object which is fully testable. Okay, so since you write lesser code, your UI design is much more cleaner, and this is the best thing that we achieve, which is the decoupling of the UI visuals from the logic, which is the visuals is something that you can do away without testing, and the logic is something that you really want to test, so you can just decouple those things. So this was still, now it was about responsiveness. Let's talk about what is MVVM. So it's the model view model. It's one of the architectural pattern which is used in WPF and Silverlight development. It's a cleaner, modular, testable, data bound, maintainable, blendable architectural pattern. So MVVM is peculiar to frameworks which support features like data binding. We'll soon see how. Few references around that. So I think this slide will be shared to you, so you can later on go through these references. And these are kind of good talks by Joe Smith and Lauro Binio on MVVM, which they presented in Mix 11. Okay, so what is MVVM? What we are really trying to achieve here is a better testable code of my UI. The MVVM starts with the model. When we talk about model, it's basically my business model. My business model has all my logic, all my data, and it is concerned with how my application behaves. So my model says I'm only concerned with the business logic, and I do not care how the data will be shown on my UI. So there is separation of concerns. There is very cleaner responsibility given to, and aware that there is a separate view as such over it. It thinks that, okay, if I am the view, what are the kind of properties that I would want to show to the user? which I can extract it from the model. And I have UI logic, but do not know the UI design on how properties will be displayed. So the view model says that, okay, these are the list of properties that I have that I want to show to the user, but I do not really know how these properties are going to be displayed to the user. Will these be used using a text box, or will it be a button, or will it be red in color, white in color? I do not know that. I just know that these are the values that we want to show to the user. And how does the view model communicate to the model? It says, I will call methods exposed by model whenever a command is invoked on me. So view models have commands. Those commands, whenever they are invoked by anybody, the view model will call the appropriate method in the model. So the view model also does not know why a certain operation is done. It just knows that if a command is invoked, I have to call a particular operation in the model. And whenever my model computes a value and my task is complete, the model wants to tell it to the outside world that, okay, I'm done with my calculations and I want to publish the results. So the model does that using data binding, and it says I get notified of the property changes in model and set my UI properties accordingly. So this model, it can be actually two types of it. In applications which are like mostly WPF applications, your model has a lot of UI logic. It's a lot of business logic. It's an actual application which has all your business objects and the interaction between those business objects. But in cases like rich client development using Silverlight, many times you may just have these models as DTO objects because your logic will actually reside in your server on the service side. Okay, and then on top of this is the view layer, which says I have all the UI controls to show the VM properties to the user, and I have style, school effects, but I am dumb because I do not know why I do what I do. I just pick up properties from the view model and show it in the UI. So all that the view knows is about the view model. It says that, okay, my view model exposes these properties. I have to show these properties in a better way on the UI. So whenever the user interacts with the UI, the user clicks on a button, I want to notify this to the view model. My controls are bound to the view model commands, which are automatically invoked on user inputs. So the views controls are data bound to the view model. So we do not write any extra piece of code for that. There is no code behind. Using data binding, these controls are directly mapped to the commands in view model. Whenever the user invokes these controls, a command is executed in the view model, which will then call the model. And similarly, I get notified of property changes in the VM and automatically show them on the user on the UI through data binding. So whenever my VM properties are changing, those properties are data bound to the UI controls. I do not have to write any code behind, and they will be automatically propagated on the UI. So this is basically what MVVM is all about. And if you see, it makes heavy use of data binding in all its layers. When a view wants to call something in the view model, the commands are data bound. When the view model wants to show a property on the UI, those properties are also data bound to the UI controls. And what we really achieve here is the testability of code. So now my model and my view model are really just plain old C# objects, which are fully testable. I can do unit testing of those. And what I've really achieved is a separation of my view and my model. I can keep changing my view, and that will not impact the behavior of my application. And I can test them separately. So this was about MVVM. Now we are going to see how do we achieve responsiveness in MVVM. Before that, why is MVVM not responsive? Because of one single reason, that all this interaction happens in a single thread. Like your view calls the view model, your view model calls the model, and vice versa, the response from model to view, they're all in a single thread. And this makes your MVVM pattern very unresponsive. I'll just show you an example of how it can be. So this is one simple application which we'll be using throughout our session. There is one button here which will increment this counter. It will keep incrementing in a for loop. And there is another button which will decrement this counter. So when I click on this button, I expect my incrementing counter to show up continuously, and at the same time I should be able to initiate some other task like decrementing a counter. But this is an application which has the problem, which is single threaded. If I click on that, you see I do not see any updates here. Also, if I click on the decrement counter button, this does not really work. And the UI will update only once the whole counting is done, and now it shows me the final result. So this is something that we do not really want. We want the updates to show up on the UI continuously. And while the updates are happening, I should be able to start some other task. Okay. So what are the solutions to make MVVM UI more responsive? Before we go into that, let's quickly look at the code that we had to get an understanding of how UI is designed using MVVM. It's small in size. Okay. Can everybody see the code? Okay. So this is what my model looks like. Yeah. So I have my model has these properties as counter 1, counter 2, and then there are operations which works over these properties. I have an operation in my model as increment counter. This will just, in a while loop, it will just keep updating my counter. It will just increment the counter. And whenever my counter is updating, my model is actually sending an event out of itself. It's raising an event saying the counter value has changed. And this is what is provided by the MVVM framework by WPF, the iNotify property change. It's an interface which has this event. Basically, you can raise this event whenever your property changes on your model or the view model. So I call this method wherein I just verify that the property exists, and if so, I raise this event. Whenever my model is raising the event, my view model So my view model, it wraps the model in its constructor, and then it says whenever my model property changes, look for corresponding property in the view model and raise that property again for the view. And the view model does not really know that a view exists. It just says that, okay, I've raised an event that this property has changed. And similarly, it provides corresponding properties in the view model, which the view can either use to get properties or set properties. And then there are these commands. So there is an increment counter command which will be data bound to my UI, and whenever I click on that button, this command gets invoked, which basically says do a model.increment counter. And here is the UI. My UI had, it's a simple UI with just a button and a text box. So I had this increment counter button wherein I say so I have bound a command to my button, and it says bind the increment counter command of my view model to this button. And I have a text box which will show the counter properties. This text box, which is the text property of that, will be bound to the counter 1 property. So here if you see, the text property of this control is bound to the counter 1 property. So I have not really written any extra piece of code to make sure that whenever my counter value changes, it has to be propagated to the UI. This will happen automatically using data binding. And yeah. So this is about how my model view model code looks like, and this was the problem statement that we had. Now let's try to look at what are the various solutions we have to solve this problem. Okay. So one is the various obvious solution using multiple threads in my model. We'll see that in detail. Then using threads in my view model, I'll see why this is required. Then a better thing to do is using a thread pool. We'll explore this new feature of C# 5.0, which is the asynchronous feature that they have introduced, which is really a very powerful thing. And using batch updates of UI, and then using virtualizations of UI controls. So using multiple threads in my UI model, this is the first step towards UI responsiveness, and just show you the code first. This is my solution. What I have done is it's the same thing as my problem statement. It's just that instead of yeah. So my model now, instead of doing that while loop in a single thread, it says that okay, do this thing in a new thread. So that my UI thread, which had called this model, is now not blocked, and I can do my operations irrespective of that. I can free up the UI thread for user interaction. So let's run this thing. It won't be a perfect solution. You'll still see some glitches, and we'll discuss why those things are. Okay, it looks like a Murphy's Law thing. It's not running right now. Maybe it's running in the background. Yeah. Yeah, this was the feature security. So this is one of the solutions to make my UI responsive. If I click on my increment counter, you can see that now the value updates are being shown up, but still there are some glitches. It's not just happening. And while this is happening, I can still click on decrement counter, and even my other counter is decrementing. So we have achieved two things. One is my UI updates are showing up, and secondly, I can, while one operation is going on, I can initiate some other operation. But you can see it's not a perfect solution. There are glitches in this. So one thing that we really observed is that although this is in a new thread, this is still doing a counter update in a for loop, which is going to hog your CPU. And one of the solutions to that is, so this was just a demo piece of code. Normally in your real-time applications, you won't be doing a CPU intensive operation all throughout. Even if you do, in cases where you're using a thread, you have to introduce some thread sleeps to make sure that the UI dispatcher thread gets some CPU to update itself. So the decrement counter that we had was using a thread.sleep, and so you'll see, although my increment counter was not moving very smoothly, if I click on the decrement counter, this is kind of very smooth because it leaves the CPU for some time so that the UI can update itself. Now, one of the problems that we see here, okay, did you notice one thing, that although we created a new thread in our model, the update to the UI was happening even without using a dispatcher thread, because by the law of the dispatcher that we saw some time back, if I am doing my operation in a new thread, when the results come back, the UI has to be updated using the dispatcher thread only. But I have not written any piece of code to make sure that the dispatcher thread is used. This is because in data binding from .NET 3.5 onwards, they have automatically marshaled all the iNotify property changes to the dispatcher. So whenever my view model raises any kind of iNotify property change event, my data binding will actually work on the dispatcher thread. So I do not have to take care of that anymore. So that's a good thing. But then the auto marshalling happens only in case of I notify property change and not in case of I collection property change. What I really mean is this. So this is another. Yeah, this is another problem statement of the responsiveness in UI. Earlier one that we saw was about updating one of the properties in my existing controls. This is about showing collection of controls in my UI. So let's say if my view model has thousands of items in my collection, and I want to show all those collections on the UI. When I click on this button, this is internally going to add a lot of controls to a list of controls, and that is going to show up in the UI. But if I just click on this, you'll see nothing is showing up on the UI, and I cannot click on any other button. This button apparently is supposed to show me a message box just to show that my UI should be responsive. So that did not happen. The UI was hung for quite a lot of time till my items were being added. So all these red boxes that you see are kind of small items that I have added in my list of controls in the UI. So how could we, and what we really wanted to achieve was this. If I click on this, my items will be added, and as and when they're added, I can see the updates. I can also initialize some other operations on my UI. So this is achieved. So you normally show a collection of items on a WPF UI using an observable collection. So an observable collection is a collection item wherein if you keep adding and removing items, that will reflect on the UI automatically if my UI is bound to that collection. But this is not handled in .NET 3.5, and if you are adding your item on a new thread, you have to make sure that manually you use the dispatcher. If you look at this piece of code, in my new, I was adding new items to my list of collections in a new thread. If I directly run this code, it will not work, and it will show me the same exception saying that the object should be added only by the thread which created the control. For that, we have to do some tweaking. We have to extend the observable collection item. I have picked it up from a very good blog by Muljady Budman. And what we are basically doing here is whenever a collection change event is raised by the observable collection, this guy takes a handle of it, and it invokes the handler using the dispatcher. A simple thing to do, but this makes sure that whenever I am updating my model in a different thread, I can show that change on my UI. Okay. So this was that point that we were talking about. I notify collection change is not marshaled to the dispatcher, so you have to handle it explicitly. And if you have noticed one more thing, this needs change in all your model operations. So we were doing new thread and my operation. I have to do this thing in all my model operations. And for an application developer, this kind of becomes a lot of headache, because he has to run all his operations in a new thread only because the UI should be responsive. And the application developers do not really want to be concerned with the UI development as such. They just want to concentrate on the business logic. And that's why expecting that all your model operations will happen in a new thread is not a viable solution. So what do we do in that case? We can do the same solution, but instead of doing a new thread in your model operations, you can do a new thread in your view model. So if you look at this, here this is the other solution wherein my model still shows my operations in a single thread. Here, but then if I look at my view model code, so relay command is the command that we use for invoking like executing a command on the view model from the UI side. So we are saying all interactions to the model happen through the view model, and that happens when the user clicks on any control on the UI. That means all executions happen through the relay command. whenever the user is clicking on a button, this command gets invoked, the execute method of the command gets invoked, and that calls the model operations. So what we can do is, in the execute operation, instead of just calling the model operation, you can do that in a new thread. So basically what you have just done is, instead of writing new threads in all your model operations, you just made sure that at one place you just give a new thread, and your UI will be responsive. So basically if I run this solution, it will be the same thing as earlier one. A new thread will be created for every call to the model. It's just that the code is much maintainable now. But if you look at this problem, this still has a few problems that we have to deal with. Thread creation at only one place is what you have seen. This is not very efficient because whenever the UI clicks on any control, you are creating a new thread to invoke your view model, to invoke your model operations. This creates a lot of problem in the garbage collection of the thread. Like you have to make sure that you maintain the life cycle of the thread manually. Otherwise, even if your application closes, your background threads may still be running and hogging CPU cycles. So what we can do to prevent that? Don't use threads directly. Use a better abstraction, which is the thread pool. So thread pool is nothing but a collection of threads which manages the life cycle of threads properly. This has efficient thread lifecycle management, and it reuses your existing thread. So if once my thread has done its operation, it does not garbage collect the thread. It just puts the thread back into the pool so that it can be used for further actions. So to show you a piece of code. So this is my same code as the earlier one, but instead of using a new thread, I am just calling the thread pool and getting a new thread to do my task. So it's basically doing it's still executing the execute function, but using the thread pool. Now, using threads, yeah. Yeah. Okay, we can run that. Now it won't be that, it will just create a new thread, but what will happen is when the call comes back from the model to the view model, and now from the view model, when it raises an event that a property has changed, the view which is data bound to my view model, it will handle that event, and there as I showed you that I notify property changes from view model to view, they are automatically marshaled to the dispatcher thread, meaning that whenever that change happens, my framework will make sure that the UI is updated using the dispatcher thread. Yeah. No. So you can always call the dispatcher and say that do this operation in using the dispatcher thread. So whenever the queue of the thread is empty, it will get that operation and execute it. So this is the solution using the thread pool. You see this is happening, and I can also click on the decrement counter, both of them happening. But you still see those glitches, right? It's not really updating smoothly. Like my increment is working, the decrement is working. This is because my thread has basically hogged on my CPU, and the dispatcher is not really getting enough CPU cycles to update the UI. If I put those thread.sleep in between somewhere, or if I do any operation which is non-CPU intensive, my UI will get enough space to do it. So there is a solution for this. So in C# 5.0, they have introduced a great feature for async operations using the new async and await keyword. This is basically users had a lot of problem, developers had a lot of problem implementing async operations in past. They have made async operations write the same way as you would write a sync operation, and this uses the concept of task, which is kind of a better abstraction than threads. It's an object which uses parallelism in .NET, but it handles threads much more efficiently. It uses thread pool within itself. So it gives you a good abstraction over your thread pool. It efficiently handles your thread lifecycle, and also it gives you a good API over your good API to work with. So you can always look at what is the current status of my operation, and you can cancel your operations and do a lot of things. So it's much more efficient than threads, and it's better API. So async operations, they are. So if you look at the documentation, they are actually kind of a sugar-coated way of the way we used to do async operation before. Before we would always write an event handler for what to do when my async operation completes, and write my code within that. They have just made the code look much more simpler and cleaner. So, and one more advantage of using task is that you can actually parallelize a lot of your activities in your code. So let's look at how we did that. So this is how I do it. I have that execute method of my relay command. Here I will be calling another method called as execute async, which is I have marked it as an async method. It just says task.run and execute. So this will make sure the framework will take care of pulling a thread from the thread pool and executing my models on a new thread. And this guy will wait for it and then show it up on the UI. So if you look at the execution using a task, it's much more efficient than your threads. So if I click on increment, now you see the UI is really updating really fast. And at the same time I can do decrement. So here I have not put any thread.sleep in my code, and still I can see all the updates happening on the UI. This is because of the efficient handling of threads that task does. And then the last remaining bit is about doing a batch update. So you just saw the UI, right? It was showing you the counter updates, but really is that much of UI refresh useful to you? An update to UI every millisecond is probably inefficient and not really required, because you are using the dispatcher thread to update your UI. It's taking away your CPU cycles, and it's not even doing anything useful to the user, because you do not really want to see the updates happening every millisecond. So what you can really do is use tasks to batch the batch update UI in smaller chunks of time. So if you see here, I'm using the same async operation that I showed you in the last example. So you have the execute async, and then you are running a task. But now in my view model, whenever my model changes, my view model gets notified. And now the view model needs to notify to the view saying that my property has changed. Here, instead of directly changing the property, what I do is I keep the change properties in a list. I don't change the property directly, and I say update UI method, which basically gets a new task from its factory, and it says update the UI and delay for 500 milliseconds. So, and while this is happening, if a new update request comes, it will not do that. It will just wait for 500 milliseconds and then do the UI update again. So this relieves a lot of CPU cycles for you. So this is the code using the block updates. So now if you see, when I click on increment counter, it's just showing me the values in block updates. It's not really showing it that fast, because I do not really need to see the values that frequently. Here I've used a value of 500 milliseconds. Probably you can reduce that to make it show more smoothly. So these are all the things that you can do with the changes in your model and the view model. And the last thing that you can do is a change in your view. So you can use either UI virtualization or data virtualization. which means there are certain controls like virtualizing stack panel in WPF, which makes sure that whenever you have a long list of items to show, let's say you are using a list box and you have a long list of things to show, you don't load all your controls at once, all your UI control at once, because the user is going to see only which is available on the screen. So these kind of controls, they find out your screen area and they will load only those UI controls which are visible on the visible front. So this reduces your CPU cycles to a lot of extent. And then the second part is about data virtualization. So do not load data that you do not need. You don't have to get millions of data on the UI side and then show it up. There are various techniques by using which you can just get the data which you really require at the current point of time and show them on the UI. And this is the last slide about the comparison. So I just did a normal portfolio profiling of all these methods. What I observed was that models in thread and models in view thread took about 16 seconds to count about 5 million. This is obvious that they will both be same because they are both firing a new thread in every request. My thread pool was a little efficient than the earlier one because it was handling my thread lifecycle. Async was much faster. It was taking about 10 seconds to update my UI. So using task is really a good thing. And finally, the block update, when I said that I do not really want to update my UI every millisecond, just do it in blocks in chunks of time, that actually reduced the time to 6 seconds. So block update of UI using task probably is the best way of doing responsive MVVM development. Yeah. So any questions?